Thank you and good afternoon, everyone. I'm Madhusudan from Oorja Energy Engineering. We provide sustainable and energy efficient cooling solutions primarily. Heating solutions we provide mostly in the northern regions of the country. So I'll primarily focus on cooling. We've been providing these solutions for nearly a decade. And there are multiple solutions, multiple technologies we use as a part of our solution. Some of these you can see on screen, like radiant cooling, geothermal cooling. We do pre-cooling in various ways. We've done thermal storage projects where we have used thermal storage. So when we propose a solution, it's not one technology that we are selling. Depending on the building and its needs, we put together various technologies what are feasible and viable and provide a solution. So in the process, we have installed these solutions in various kinds of buildings, commercial offices, factory shop floors, even aircraft hangars and military barracks, and in various climatic conditions all over India. Today, I'm going to talk only about a couple of these technologies, but I would invite others to connect, and if they want to know more about any of these technologies that seem interesting, or we can cover them in the Q&A session. Just to get a sense of footprint of where all we have installed these technologies, the northernmost installation being somewhere close to Siachen, and then we've done southern, western, eastern states everywhere. Some of the recognition that we have got. So with this, I'll just move quickly to one of the technologies that I'm covering today. It's called radiant cooling. This is something this is a technology in which we are a leader in India. We've installed this in many different types of buildings. But let me first start with explaining how the system works, how this technology works, or rather the principle behind this technology first. Cooling to me is taking the heat away. Excuse me. So this heat can be taken away in multiple ways. If you go back to maybe our 7th or 8th standard science and recollect, heat transfer can be done by conduction, convection, and radiation. But today we see that almost entirely, especially for space conditioning, we seem to be doing the cooling only through convective cooling, where we cool the air, cold air comes, picks up the heat from the space, goes by, cools again, comes back. Right? Now, instead of that, imagine we make the entire floor or ceiling a heat exchanger, where we embed a network of pipes and circulate cold water in it. The surface becomes cooler. It absorbs heat from all other heat sources in the space, walls, people, equipment, and takes away this heat. So this is how it works. It can be done in various ways. We embed piping in the floor, call it floor cooling. We do it in the slabs. We manufacture panels or baffles, as you see in my background, which act as cooling surfaces, cooling devices, and they provide radiant cooling. I just wanted to explain this a little further and compare it to what we are already aware of. In the conventional HVAC air conditioning system, what we do is, if we have to cool a room at 24 degrees centigrade, return air at maybe 24, 26 degrees centigrade is passed over a heat exchanger, a coil in which chilled water is flowing at maybe average of 9 degrees centigrade. Now, this air and this coil is the only place where the heat exchange happens. The entire heat exchange of whatever space is being cooled happens here, and therefore this is a very dense heat exchange. It needs to happen in like less than a second, that particular heat exchange needs to happen, and therefore the coil temperature needs to be very cold, right? And air is pumped in through the ducts. So radiant cooling doesn't change, excuse me, doesn't change the need for, as they say, the high side equipment or a chiller. However, it brings the efficiency there, but changes the way we distribute the cooling. So it eliminates the need for an air handling unit or a duct. Because imagine if the coil that you see, imagine the coil that you see there in the air handling unit. If I were to remove that and bring it into the space, if I remove this from here and bring it into the space that it is being cooled and spread it all over the ceiling, then you wouldn't need this fan motor. Also, the coil doesn't need to be that cold now that there's the surface area has increased so much and can be at a higher temperature. So that's why in radiant cooling we typically use the chilled water temperature at anywhere between 16 to 18 degrees centigrade, which leads to a better performance by the chiller, at least by 30% or so. But you still are able to get 24 degrees centigrade room temperature. So this is what allows, and the second allows us to have lower energy consumption. And the second reason is we are not using air as a means of heat transfer, because if you compare the heat transfer by 1 cubic meter of air versus 1 cubic meter of water, there's a factor of almost 3,400. That is a different. So the transport energy that is required to provide 1 ton of cooling would be way higher if you were to use air, because you require a lot more volume of air than the transport energy that is required when you use water. So these are 2 reasons why radiant cooling provides anywhere between 30 to 50% energy savings in cooling, depending on what you're comparing it to, right? Will not go into this. This is some of the examples of installations, mostly in office spaces. This is an office building in Jaipur where we provide cooling as well as heating in this space using a reversible heat pump. An exhibition space in Delhi. This is a warehouse for a pharma company where 365 days, 24/7. 22 degrees plus or minus 1 degree and 50% RH has to be maintained. Here what you see are on the ceiling, these are radiant cooling panels that we manufacture. And even on the walls, what you see is radiant cooling panels. In this particular case, we were able to bring down the connected load itself by 60%. There's another shop floor in Chennai where radiant cooling was implemented by us. You see those panels on the ceiling. And this is an aircraft hangar, another structure where ceiling is high. Of course, this was done for, this was used for in Srinagar, so we had done radiant heating here. The related technology is structure cooling, where we do not use what I mentioned. If you remember, in radiant cooling, we use temperature, chilled water temperature between 16 to 18 degrees centigrade to maintain 24 degrees centigrade. Now, there are spaces which don't need to be maintained, don't need to be maintained at 24 degrees centigrade, are fine with 26 to 30 degrees centigrade. In which case, depending on the location, we can avoid use of chiller completely or chilled water completely and use some other heat sink. And that's what we do in structure cooling, where the primary objective is to remove the heat that is being accumulated by the concrete structures. If you see, if we are inside a building and the sun comes out, dumps it, heats and goes away, it is dumping the heat in the building structure, thermal mass accumulates that heat and re-radiates it in the night. That's why in summers these days, even in the night, we feel hot inside our house and we use air conditioner. Whereas if you really think about it, there is no heat source in the night. The temperature is 26, 27, 28, not a temperature that would require air conditioning. But you still require air conditioning because your building has accumulated the heat during the day, and that is being re-radiated. So if you flush this out, you do not require air conditioning in the night. So that is to flush and we did some thermographic studies. I'll maybe quickly jump to it. If you see the thermograph on the left, this is the temperature taken at 8 p.m. when the ambient temperature was 25 degrees centigrade. And this is the temperature on the right. You will see the surface temperature of the shed at 82 degrees centigrade in the afternoon. Just shows that how much we underestimate the the thermal capacities of the structures that we occupy, whether for residence or for work. So in structure cooling, the difference is nothing. We eliminate the chiller and use a cooling tower, a multi-stage cooling tower, or any heat sink we can use, a wastewater heat sink or treated water tank is available. The entire reason is just to take out the heat that is trapped in the structure and dump it, so that it provides a base level of cooling. Different buildings that has been where it has been installed. This is the dormitories in IIM Raipur, excuse me, where you don't need to provide air conditioning, but you need to provide comfort. So they're using structure cooling. This is another place where this is an architecture college in VIT where this has been used. There's another installation in Chennai, commercial building, where we have implemented it in a hybrid mode, where normally they would have used 40 tons of split AC. With structure cooling, they have installed only 13 tons of cooling. Okay. This is another installation in Pune. So that is it from my side. I hope it was in time and there is some time for any questions that people may have.
Yes, thank you so much, Mr. Madhusudan. Again, a very informative PPT. I will now open, we are now open to take questions from the audience. So if there are any questions, you can either write them down in the Q&A tab and we'll be able to take them for you. So while our audience thinks of the questions or while something comes to their mind, I wanted to ask, again, for the benefit of our participants here, are there any potential risks the component manufacturers need to be aware of while installing this system?
I would say the limitations would be if it's a concrete building, if it's an operating building, then it would be difficult to install this. This is usually better to be installed if it's a greenfield project or when you're remodeling. We have done retrofits, but it depends on what the building is. The second thing is, which is a requirement even for air conditioning. Basically, the building needs to be airtight. There are leakages, especially unfiltered air is coming in. In those places, one has to be really careful because the chances of condensation are there. Having said that, we have installed these systems in one of the most remote places, just 1 kilometer away from the seashore. There are installations, and there has been no condensation for the last 7-8 years, right? So it really depends on the building. But one has to be aware that if your building is leaky and not airtight, then radiant cooling may not be a solution for you. You should more look at the structure cooling.
Right. One more thing, while we are, when we are talking about these embedded pipes or tubes, is there any chance of an interference with the existing processes or existing equipment in the buildings?
No, not really. I mean, piping and ducting and all these are part of industries anyway, or buildings anyway, right? So as long as you have a path, that is not an issue.
Right. We have a question from Mr. Naveen Kumar. I will read it out to you. Availability of water is also a big challenge. Today, CGWA have strict regulations to use water and recharge percentage of used water. So how your project is comfortable to implement?
So one thing to understand is that we are only using water as a heat transfer medium, not consuming it. In radiant cooling, water goes, it's just like a chilled water system. In radiant cooling especially, it's a closed loop chilled water system, cools, comes back. It's just that instead of doing at 7 degrees centigrade and 12 return, which you do in conventional cooling, we are doing it at 16 or 18 degrees supply and maybe 20, 21 return. So there's no consumption of water for the radiant cooling per se. Now, whether you're using a water cooled chiller or not is applicable to both, whether you're using a conventional HVAC or a radiant. So that's left up to you. But the radiant cooling by itself doesn't use any water. They just use water as the heat transfer medium.
Right. So there's no consumption of water per se. Okay, I hope that answers your question, Mr. Naveen. I believe we have another question. This is a comment from Mr. Naveen. Structure cooling has cooling towers.
Yes, structure cooling has cooling towers, no doubt about it. So what we typically do is, if it was related to structure cooling, is we typically use treated wastewater that's available, and wherever there's a problem of water is not available, it's a treated wastewater. We use it in two ways for structure cooling. Either we do tertiary treatments and so that it's suitable for cooling towers, or in some cases we use the treated wastewater itself as a heat sink and immerse the heat exchanger in it and dump the heat in the water itself instead of evaporating the water. I hope that answers Naveen's query.